Chapter 1, History of Engineering. The questions that we'll answer in this video: when did engineering begin? What were some of the first engineering designs? And what are the first steps to becoming an engineer today? We'll begin with the Mesopotamians. They invented the wheel and the wheeled cart. The Sumerians built canals, walls, and temples. The oldest astrolabe, dated around 2000 BCE, was found in ancient Mesopotamia. The Babylonian king Hammurabi created the first building code, providing a system for administering penalties for poor construction, and around 700 BCE, the Assyrians completed the first public water supply. The Egyptians. The Egyptians had some of the first irrigation. Irrigation is the application of water to crop-producing land through artificial means. Due to the fact that the ancient Egyptians had begun irrigation, they had ample food supply. Because they had ample food supply, they were able to focus on social and cultural development. The Egyptians and the pyramids. The Egyptians are best known for the pyramids. There are three famous examples still standing at Giza. The largest pyramid is known as the Great Pyramid at Giza, or the Pyramid of Cheops. It stands 481 feet high and covers 13 acres at its base. In ancient Egypt, the king chose a trusted individual to serve as its chief of works. The chief of works is analogous to the appointment of the Secretary of the U.S. Department of Transportation by the President of the United States. The Greeks. The Greeks were able to focus their efforts on harbor construction and shipbuilding. They were the first to construct a lighthouse built at the port of Alexandria in what is now Egypt in 300 BCE. Athens' leaders sought to make their city the most beautiful metropolis. Pericles gathered the best builders to create well-known shrines, statues, and structures. The Romans. They kept things simple in design and form, but massive in scale. The civil engineers of ancient Rome focused on public works projects built by slaves. The Romans are known for their bathhouses, arenas, roadways, temples, and public forums. Roman engineering feats include new construction methods and construction techniques. They developed cement and developed numerous construction machines such as the treadmill, hoist, pile driver, and wooden bucket wheel. The Middle Ages. This was a slow time for engineering developments. We do attribute some advances in structural design to medieval inventors. They also developed energy-efficient machines and power-saving devices. During the Middle Ages, China invented gunpowder, papermaking, iron casting, and textiles. Technology that continues to improve. Johann Gutenberg, who lived from 1398 to 1468, invented the movable type mold. Gutenberg is credited with the first printed book in AD 1450. The Gutenberg press came at a time when societies felt a growing need for a convenient way to share information. Technology before its time. Leonardo da Vinci, who lived from 1452 to 1519, used his artistic talents to observe and illustrate how machines work. With the knowledge he gained, he was able to make mechanical improvements and invent new machines. Leonardo's inventions included musical instruments, hydraulic pumps, reversible crank mechanisms, fin mortar shells, and a steam cannon. Connections between science and engineering. Robert Boyle is credited with Boyle's law, which states that if the volume of a gas is decreased at a constant temperature, then the pressure increases proportionally. This law helped to form an important body of knowledge underlying many pneumatic concepts. Robert Hooke, 1635 to 1703, worked for Robert Boyle. Much of Boyle's work might have been inspired by work carried out by Hooke on clocks, springs, and gases. Hooke published an important book called the Micrographia. This book became the foundation for the science of microscopy. Microscopy is the use of a microscope for investigation. Hooke's use of the microscope led to fascinating discoveries and new inventions. Connections between math and engineering. Leibniz, who lived from 1646 to 1716, and Sir Isaac Newton, 1642 to 1727, are both credited with creating calculus. There are two different branches of calculus. The first, differential calculus, which determines the slope or steepness of a complicated curve, and the second, integral calculus, which is used to find the volume of a complex figure. The age of transportation. In the 1760s, James Watt's working model of a steam engine led directly into the age of transportation. Steam engines as power for transportation. Collaborating with Matthew Boulter, Watt produced hundreds of steam engines. The Boulton and Watt engines were used in England during the 1800s to pump water out of mines and to drive machinery that helped power textile mills and ironworks. Experimentation led to advances in steam engine technology. Those advances made steam engines useful in transportation. The first commercially run steamboat, the Clermont, was created by Robert Fulton in 1807 and ran between New York City and Albany on the Hudson River. In 1823, George Stephenson demonstrated that the feasibility of a steam-powered railroad transportation system. His invention sparked the growth of the railway system. The age of transportation, canals as conduits for transportation. Extensive canal systems were being constructed in England from 1780 through the 1900s and in the U.S. during the first half of the 19th century. Several important canals improved transportation in the United States for the first half of the 19th century. There was the Erie Canal, which was constructed between 1817 and 1825, that connected New York State cities between Buffalo and Albany. Ohio and Erie Canal, constructed between 1828 and 1836, connected the Cleveland to Portsmouth on the Ohio River. And finally, Chesapeake and Ohio Canal, which was constructed in 1828 to 1850, which connected Washington, D.C. to Cumberland, Maryland. We still rely on the Panama Canal to facilitate international trade. The need for better roads for transportation. The number of autos on the road exploded in 1904 when Henry Ford implemented his vision of the assembly line to mass-produce high-quality, affordable vehicles. The era of rad building was first influenced by John McAdam, who devised a method for compacting and crushing stone. The Federal Aid Highway Act of 1956 authorized federal funding to build more than 45,500 miles of paved roads in the U.S. Taking to the sky. Brothers Orville and Wilbur Wright first achieved success in 1903 with a 12-second, 120-foot flight. In 1905, Charles and Gabriel Voisin started the first aircraft company in France, building custom airplanes. Moving underground. Engineers first envisioned a channel tunnel or channel in the early 1800s. The age of electricity. Countless scientists have worked to develop electricity as a source of power. Electricity is the transfer of energy through the flow of electrons through a conductor. When you use a battery-powered device, you are using a battery in the form of direct current, or DC. In alternating current, AC, the electrons move back and forth at very high speeds. Nikola Tesla played a major role in deciding how we use AC today. Tesla's inventions influenced how electricity is generated, transmitted, and converted to mechanical power today. Inventors and innovators in the 20th century took full advantage of the power of electricity to create numerous applications that would vastly improve the quality of life. Energy Star is a joint program of the U.S. Environmental Protection Agency and the U.S. Department of Energy. Engineers have improved the quality of life by designing systems for supplying clean water, developing genetically modified crops, and creating better medicines and medical procedures. Engineering societies. John Smeaton was the first person to call himself a civil engineer. Smeaton created an engineering society in 1771. In 1881, the Institution of Civil Engineers was formed. Thomas Telford was elected as its first president. The Institute of Mechanical Engineers elected George Stephenson as its first president. By 1908, civil, mechanical, electrical, chemical, and mining and metallurgical engineering all had societies in the United States. Some different engineering societies: 1852, American Society of Civil Engineers; 1871, American Institute of Mining, Metallurgical, and Petroleum Engineers; 1880, American Society of Mechanical Engineers; 1884, Institute of Electrical and Electronics Engineers; 1908, American Institute of Chemical Engineers. Preparing for the field of engineering. In high school, you may take classes such as CAD, physics, engineering, and robotics. In college, you will earn a Bachelor of Science degree from college or university. Plan a visit to the college campus to ask professors questions. Engineering programs are accredited through the Accreditation Board of Engineering and Technology. This is an organization that helps standardize the requirements among college and universities. Preparing for the engineering field. After receiving your degree, you will likely do one of two things. You might enter the workforce in your area of specialization, or you might pursue the secondary degree in your area of specialization. A test is required for you to become a licensed engineer. Some colleges offer a co-op or work-study program. Many times a co-op leads to a full-time job. What do engineers do? The major engineering categories are civil, electrical, chemical, and mechanical. Aerospace engineer. Aerospace engineers are concerned with engineering applications in the areas of aeronautics, the science of flight, and astronautics, the science of spaceflight. Aerospace engineering will be responsible for making interplanetary travel possible. New propulsion systems will require that engineers venture into areas never before imagined. What do engineers do? Agricultural engineer. As farming and efficiency increased and people left farming for jobs in industry, fewer farmers were needed. The application of new technologies and engineering to agricultural practices has vastly increased farmers' efficiency and productivity. Agricultural engineers design machinery to plant, fertilize, and harvest food crops. They design structures for crop storage and develop methods to conserve soil and water. They produce new seeds and plants that are genetically engineered to resist pests. Chemical engineering. Chemical engineering began its rise to prominence after World War I. Chemical engineers are involved in the manufacturing of polymers, drugs, paints, pesticides, cosmetics, and food. They work in oil refining, paper products, and textile manufacturing, and the extraction of metals from ores. Civil engineering. Civil engineering provides communities with structures such as buildings, bridges, dams, and roads. Civil engineers are concerned with planning, designing, and supervising the construction of structures. Civil engineering focuses on structures and structural systems such as bridges, skyscrapers, tunnels, rapid transit systems, highway systems, recreational facilities, industrial plants, dams, nuclear power plants, railroad lines, harbors, and offshore oil and gas facilities. Computer hardware engineering. All organizations depend on computers to manage inventories, create invoices, record sales, and communicate with customers. Electrical engineers. Electrical engineers solve problems using electrical principles. These principles are relatively new to us. George Ohm and Michael Faraday were only beginning to build our understanding of the science in the 19th century. Electrical engineers include Thomas Edison, who supplied DC electricity to New York City in 1882, and Marconi, who made the first wireless radio transmission in 1896. Industrial engineers. Industrial engineers study engineering principles and techniques that can help make manufacturing processes more efficient and more profitable. Their efforts can help customer service and product quality, make workplaces safer, and make more work easier. Mechanical engineers. Mechanical engineering deals with power and its generation and its application. Power affects the rate of change or motion of something. This can be a change in temperature or a change in motion due to its outside stimulus. The breadth of study required to be a mechanical engineer allows students to diversify into many other areas. The major specialties are applied to mechanics, control design, engines and power plants, energy, fluids, lubrication, materials, pressure vessels and piping, transportation and aerospace and heating, ventilation, and air conditioning. Answer the following questions in your engineering notebook. What are the important pioneers in the field of engineering today, and what did they contribute? What advances in technology spurred the growth in engineering fields? Describe the difference between a scientist and an engineer. Describe two aspects of the ancient Roman engineering that distinguish it from ancient Greek engineering. What invention allowed scholars to spread their knowledge more quickly through the 15th, 16th, and 17th centuries? How did the steam engine adapt to use in transportation systems? What major construction projects were completed during the 19th and 20th centuries that led to better and faster travel? Name some important figures in the history of flight. What did Volta invent to provide direct current to today's portable electronic devices? What did Tesla do to influence the way alternating current is used today? Name the 4 branches of engineering. What specific engineering disciplines interest you the most and why? What traits or attributes make an engineer successful? And what post-high school education do you need to become an engineer? Answer those questions in your engineering notebook. Thanks for watching.